It's worse than trapezium.
It's what?
It's worse than.
It's worse?
Yeah.
What are you talking about? Let's see.
It's more complicated.
No.
LibreOffice. What is that?
What?
Like a word.
Or the library?
Libra.
So we have to wait to
Is that the door? Is this Lee now? Are you back?
Where's this?
Did you lose him?
Where's
Okay, fine.
Was it really new one?
You didn't lose him then.
From China.
Your friend? No.
We're still waiting for Lee. What's taking him so long?
No.
Right now.
Yeah, the news.
No, we're waiting for. Where's Lee?
It's coming.
Is he in this building?
It's full.
Let me do
Might as well get my spreadsheet ready for later. Oh, it's only Lee.
Where are they?
I brought you guys something.
Did you really?
Chocolate?
Because you're making that. You remember that look I was talking about?
Ta-da!
Oh, okay.
Thank you. Wang.
It's a long
What the fuck is this now?
I know.
What is this?
This means king. This
Is this
means
Malaysian?
day.
I don't think so. Actually, some.
You will say to them.
It's
Yes,
Taiwan.
kind of.
Yeah, it's
Right.
Taiwan.
What's it taste like?
Oh,
Taiwan.
Salty cracker.
I want to bring durian sweet for you. Do you know what durian is?
It's very smelly.
It's a king of fruit.
Oh, I don't like that.
Yeah, I want to bring you there because you probably never tried that, but I forgot.
What is it? Tangerine, of course.
It's durian.
It's durian.
It's
Durian
durian.
is.
Oh, no problem.
It smells really soft. It's kind of.
Okay, we'll continue.
Why do you want this taste to me?
From China.
Ni hao.
Sorry, he got that. No. Yes. He got the ni hao already, so I think Jerry said it to him. Okay, so we'll continue now. So last time we were looking at the Trapezium Rule, and we actually had a look at a couple of examples. And would you remember the rule off the top of your head for the integration? Let's see. A to b f of x dx. Would you remember the rule? What does it start off with? A half, yes. H,
YA plus YA.
f of the first one plus f of the last one, yeah. Yeah, plus twice add up everything else. And the key idea, what did we imagine the shapes as here?
Like wave.
Yeah, which are what shapes? Yeah, we imagined each piece to be like a rectangle with a triangle on the top. The idea behind Simpsons Rule is that instead of thinking about them as little rectangles and triangles, we'll do this. Let's just draw the curve here. So we'll draw one straight up here, one straight up here. In the Simpsons Rule, you look at them in two bands. You look at them in groups of points of 3. And the way Simpsons Rule works is that it imagines there's a quadratic connecting the tree and gets the area under the quadratic. This is kind of the key difference. Yeah. Now, why might that be better than using straight lines? In other words, what's so great about drawing a curve, a quadratic, to connect 3 points rather than drawing a straight line to connect the 3 points? Yeah, but why? Like, yeah. Really, the key difference is because it's a curve and the thing you're integrating is probably a curve, it'll be a closer match than if you just draw a straight line. So it should be more accurate. And it usually is, although there's some exceptions. It usually is. So let's have a look at what Simpsons Rule is. And in fact, when you see what Simpsons Rule is, you realize it's not that much different to the Trapezium Rule. Okay, so can I scroll down? Do you have? Well, that's just from yesterday, so there's nothing really there. Okay, so this is Simpsons Rule. It is that the area is roughly h over 2. So far it looks the same. F of the first piece plus f of the last. Wait, am I? Yeah. Well, oh, sorry. Thank you. My bad. That's a 3 there. Okay, so far it's a little bit different. The difference is there's a 3 instead of a 2, but now the last part is quite different. Yesterday was twice everything else. This one's a little bit different. It's twice the evens plus, you know what, actually I'll put this in red since it's different, plus 4 times the odds. And I'll explain that now in a second. I'll just write even in red. Yeah. So last time it was just twice everything in the middle. This one is twice all the even x's plus 4 times all the odd x's. And I'll explain this with an example. We'll use the one we did yesterday, which is, what was it, integrating x squared from 0 to 1, wasn't it? Yeah. Do you remember what that one was? The exact answer? 1 over 3? Yeah. So let's use Simpsons Rule. Let's get our table going and let's see what answer we get using Simpsons Rule. So I'm going to use Simpsons Rule on the integration 0 to 1 x squared dx as an example. Alright, so here's x, starts at 0, and here's fx. How many pieces did we use last time when we did this? Was it 5? Yeah. Was it 5?
5.
Yeah, so we'll use 5 again. So what is the h here if we're using 5? 1 minus 0 over 5, so 0.2. So that's 0, 0.2, 0.4, 0.6, 0.8, 1.0. Okay, that's fine. Now I need to get the f's here. So we'll use the calculator mode on our calculator again. What's that? Mode, table, x squared, 0 to 1 in 0.2s. Okay, so 0, 0.04, 0.16, 0.36, 0.64, and 1 then, as you can see on the table. Okay, so when we use the trapezium rule, all we have to do was do first plus last plus twice of all of these. A tiny bit different with Simpsons. We still have to do first plus last. But anybody have an idea what this piece, what I mean by this piece? Twice the evens?
The second time.
Yeah, the second and the fourth and so on. So, if this is first, second, third, fourth, fifth, sixth, then evens would be this one and this one. But not this one, because I've already included it here. Yeah. So I'll just write a little 2 here to remind me I'm multiplying these by 2. And then lastly, 4 times the odd. So that would be, not this one, because I already have it. This one, that's the third one. And then this is the 1, 2, 3, 4, 5, fifth one here. And I'll put a little 4 here to remind me that it's 4 times that one. So the area should be, or the integration should be roughly 0.2 over 3, the first plus the last, plus twice 0.04 plus 0.36, plus 4 times 0.16 plus 0.64. Okay, can you hit that in on your calculator? Let's see what we get. You have it already, yeah? It's not exactly 1 over 3. It came out exactly as 1 over 3. Oh yeah, of course it would. Of course it would. Well, let me just type it in. 0.2 over 3 is 0 plus 1 plus twice 0.04 plus 0.36 plus 4 times 0.16 plus 0.64. Now, normally it doesn't work out as exactly 1 over 3, but I just realized why it works out perfectly right here. Anybody know why it worked out exactly right here for this particular example? Why did it work perfectly? No, not lucky. Yes, but why would that make it work perfectly? No. Huh? No. Well, what do you mean? Yeah? What? No.
Oh, because this shape is exactly
perfect, yeah. Remember, Simpsons Rule imagines that there's quadratics between the points. But if we're integrating a quadratic, the curve will fit the Simpsons quadratic perfectly because we were doing x squared. Of course, this doesn't happen for any other example we have in the worksheet. But here it works out perfectly because it's already quadratic to begin with. Let's look at one. What was the other one we did yesterday? We did e to the minus x squared. And how many pieces did we use for that one?
1,000.
Ah yeah, before we did that one now.
3.
Oh, I thought we did 5 for that one. Was it only 3?
Yesterday was 3, but there's Simpsons Rule has 10 question with
Okay. Was it 5 for e to the minus x squared? I thought it was. Yeah. Okay. Now, what's wrong with you? Nothing. Okay. Continuing. 1, 2, 3, 4, 5, 6. All right. Scroll down. Yeah. Okay. Let's see. Let's see which one we can do. I do want you. Oh yeah, I see here. I said 4. Now, just before going on, something to say about the n. So yesterday, when we were talking about the Trapezium Rule, we imagined it as lots of rectangles like this. So the n could be 3, 4, could be anything. Anything bigger than or equal to 1 could be the n. Now, it wouldn't be great to use 1. Why would it be kind of stupid to use 1? it's too inaccurate, because if you have a curve like this and you just use 1, all you're doing is just drawing one giant trapezium like that. It's not really good. But we could use any number bigger than 1. Now, if I'm looking at Simpsons Rule, could I use 1, for example, in Simpsons Rule? No, I can't. Why not, though? Why can't I use 1 in Simpsons Rule? No. Well, remember, what did I say Simpsons Rule is doing? Quadratics. And how many points did I say? How many points do you need to make a quadratic? You need 3. When it's linear, you only need 2 points, but when it's quadratic, you need 3. If you only are using 2 points here, you can't fit a quadratic. I mean, there's so many choices. You need at least 1 more point. In other words, you need to use at least 2. To be more accurate, I need to make sure in Simpsons Rule that the n is even, so I can fit the quadratics in. Okay, so that's important to know. If you look at the examples, all the n's are even. Can you see that? 4, 4, 6, 6. Yeah. They have to be even. So yesterday I used 5 for the trapezium, but today I can't use 5. I'll use 4 instead. Can I scroll down? Yeah. So what I want you all to do, and I'll give you the, we'll have a look at the answer in a moment. I want you to calculate this using Simpsons Rule, and we'll say use n equal to, no, we'll say 6. Yes.
The n has to be even number.
Yeah.
But we just use 5 in the example.
Did I?
Yeah.
I did. Now, why was it okay for that one? It was quadratic anyways. You're right, I used 5. That's outrageous. I should never have used 5. Although I suppose I didn't tell you I couldn't have used it yet. Wait. Yeah. Tut tut tut. Well, Lee, there was 2 reasons I shouldn't have done that example. Firstly, n was, what did I say, 5, and it should have been 6. And what was the second reason that this was a stupid example? It was a quadratic already. So, there are 2 good reasons why that was stupid. Maybe I'll put example in quotation marks. Okay, anyways, let's do a real example. Oh dear. Finish, Sean? Not yet. Finished? Success? What number did you get? Oh, actually, it should be the answer. No, it's not. It should be more accurate than this, but it should be close to it. What did you get?
2. Yeah.
2.
2.1.
What one? What did you get? We're getting very different answers here. Hang on, this isn't. The way you can know if it's right is why don't you hit the integration button on the calculator and see what the true answer is before you get too excited. Dude, shouldn't that be e power minus x squared? Where's your minus? In the power.
Oh. It's 1.49.
Yeah, and Monica, you got 1.38. But how did you both make the same mistake on different calculators?
Ah, shit.
There's no minus here.
Why minus there?
Because that's in the formula. Look, no, screen. No, look up there.
No, I know, but I already defined this one.
Yeah, so
minus 2.
Yeah, but shouldn't you?
It is kind of calculation. It automatically changes the formation of.
I know, but it should still have a minus in front of the fraction.
I don't know. It's calculation problem, not my problem.
No, it's calculator problem.
Yeah.
I know what's happening. When you typed in minus x squared, it thinks you want to square the minus.
Okay.
If you do this again, put brackets around the minus bracket x squared. But then how come you got the same answer? Oh no, you got. Well, no, when you did it using Simpsons Rule, what answer did you get?
It's already. I can't undo it.
It's gone.
It's gone.
Jerry, what answer did you get?
I haven't got it.
No, Chrissy.
1.1.
Okay. Sean, what did you get? No answer.
Bracket minus x.
No.
Right.
Minus first, bracket next.
Okay.
No, I put the square inside. No. Inside. Lee, did you get an answer?
1.3.
It's the same as yours. Right, let's have a look. Right, what's the h here? 1 over 3. Right, so this is minus 1, minus 2 over 3, minus 1 over 3, 0, 1 over 3, 2 over 3, and 1. Back to the calculator, mode, table, e power. Now, just be really careful here, please, typing in the minus. Just make sure that you're not squaring the minus. So what I suggested here, you might even want to put brackets around it like this. You don't have to, but just to be safe. You want to make sure the power is a minus, that you're not squaring the minus away. Anyways, start at minus 1 and finish at 1 and go up in 1 over 3. Okay. Let's copy this. 0.3678.
It is wrong, 79.
What?
Seriously, if you type it manually.
This is right or this is wrong?
This is wrong.
Are you?
0.3679.
No, I got exactly the same table as you.
Yeah, but if you type it manually.
Sorry, I'm only listening to people with proper Casio calculators. Thank you.
Let me prove it to you.
No, not necessary. Thank you. Right, next one. 0.6 6411 and then 8948, right? 8948, yeah. 6411 and 3678, right? First, last, even. He must have made the same sign mistake.
No, but I have here minus sign there.
And now is it right?
No, different.
Oh dear. Well, hang on, let me just look at it here. Odd, 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 even, even, even. What? First, last. Yes.
I just 1.333 instead of a bonus of 3.
That's fine, because I think...
But I mean, you make that more mistake, I mean, that's more different.
No, it's okay. Once you do your calculations to 4, it's okay. Right, let's type this in.
Oh shit.
Let's see. H over 3, isn't it? Times first plus last plus twice the evens plus, I hope I don't run out of space, 4 times the odds.
Oh, me too.
I'd be shocked if that happened. My 4? Did I not mistype? Oh, thank you. 4. 4. 1.38, not 2.1. Lee, I can't hear Jerry. Which one? Oh, the red and the blue, what I'm doing. Yeah. Lee! Please. Remember? I'm sick. Alright. Jerry, what I'm doing is, well, firstly, do you know what I mean when I say even? No, okay, even is this. 2, 4, 6, 8 is even. And odd is 1, 3, 5. That's odd. So for Simpsons Rule, it's h over 3, the first one, which is this one, plus the last one, which is this one, plus twice the evens, which is the second, the fourth, and the sixth, plus 4 times the odds, which is the third and the fifth, but not the first, or because we already have that one. Yes, Lee. The love.
I got famous. So stupid.
Did you get this?
Yeah, I mean, I didn't put like 0.36 something. I put -1 and then 1
Yeah, that's right.
and rest of them I do the same thing. But if I use a 1.33, the whole is a little different because it's not.
Yeah, it'll be a little bit different.
So I got like 1.3.
Let me just write this one down. This worked out to be 1.38427, we'll say. Now I want to know what my percentage error is. So we all know we can do this on the calculator. Let's see. Integrate -1 to 1 e power minus x squared. So it's not great. It's actually quite a bit off. Let's see how much off. Let's see. Minus 1.38427, and then 8% is it? Yeah.
Why Trapezium Rule is more accurate than the Simpsons Rule?
Now, this is the reason I wanted to do this one. In fact, last year, I asked, the assignment last year was students had to investigate which was more accurate, the Trapezium or Simpsons Rule, and the function I gave them was this one, e to the minus x squared. So, Simpsons Rule is usually more accurate, except for this one here. Strangely, it seems like the Trapezium Rule was more accurate. Now, that's only because of this particular shape. I think it's quite difficult for the quadratic to fit to this shape. In other words, well, actually, I'll show you the graph here. Yeah. Can I scroll down?
See, but I
Yeah.
got 1.30.
We looked at decimal problems on this earlier.
Well, 14 point was on here actually, so I couldn't see after this, so 0.003.
Yeah.
And then I couldn't see the percentage after that one. So
Yeah.
it's accurate.
It is accurate. It does have it, even though it doesn't display it.
Yes, because it's like,
Oh, I see. Oh, yeah, no, I get it. Yeah, you can increase it. Okay, so you're getting 1.30. Well, maybe your answer is more accurate because on the Casio calculator, it's only doing this table to 4 decimal places.
One of the three.
No. Wait, hang on. What did you get? 1
3.026.
Ah, well then mine's more accurate because I'm closer to the true answer. Yes. Alright, anyways, can I scroll down?
Yeah.
So what's happening? Why isn't it working here? Okay, well this is what the graph looks like. It's very, very flat, then it curves up, and then curves down and gets very flat again. And -1 would be about here, and 1 would be about here. How many pieces did I have? 6, was it? Yeah. So, let's see. It was -1, minus a third, minus 2/3, minus a third, 0, 1, 2, 3. So the problem here, I think, Christian, I'm not 100% sure, when you try to fit the quadratic, it's kind of difficult. It's not so accurate. Strangely, I think putting straight lines here would be a bit more accurate because of the shape. It's curved, but it's actually quite steep here, and then it's quite flat here. It's a little bit curvy here. So most of the time Simpsons Rule is better, except
It doesn't matter that we increase the n or
no, both rules always get better as we increase the n.
I mean, even though we increase the n, the Simpsons Rule is still...
I don't think it will be as accurate as quickly as the trapezium for this particular one. But let's have a look in Excel. And let's do 1,000. Not anymore.
Yeah. Do we need to find the error in there then?
What do you mean?
The error.
Oh yeah, but they'll provide you with what the true answer is.
Oh, you do provide. Yeah, that's my...
Yes, exactly. Yeah. So don't worry about it. The 1/3, Jerry? It's okay. Anyways.
Can you do for us n equals 6? Yeah. Not 100.
First do 6, then do 100. Sure.
Check with proper concept.
Oh, thank you for telling this proper. Jerry? Lee? Jerry, we're going to have a look at Excel. First we'll do 6, and then we'll do 1,000 then after that. Okay, so here is the X, and here I'll put the info. So A equals, B equals, N equals, H equals. Okay, so this is -1, 1, 6, and this one is that minus that over 6, which is that. Okay. And we start off at A, and then we'll increase by this number. And we just need to go up to 1. There we go. So the integration I equals h over 3 first plus last plus twice the evens, which is 2, 4, oh no, 2, 4, 6,
Wow.
plus 4 times the odds.
Okay, what are you gonna do for
I'm already thinking that. I have an idea.
3,
1,
No,
no, 3,
5.
5.
Yeah.
Close.
Huh?
What's gone wrong?
What is this?
A1? Yes. Oh,
Oh, you missed out the bracket.
did I?
It's not animal tree.
This is H, isn't it?
D4.
D4.
Yeah.
Ah, I just did something really stupid, and somebody else did this earlier today. Tell me what stupid thing did I do?
Oh,
It's really stupid. Now don't say it. I could. Yeah.
Use it.
Oh, you use A1 like
Yes, just like Chrissy. Yes. Okay.
It's not the first.
Exponential minus this number squared. No, it's something again with the minus. Let me just put another bracket here. This should be quite small. There we go. So it means that here I should change these A's to B's. No, you're not the only ones. Right, let's see what we get now. There we go. 1.38. Yep. Okay. Let's have a look now at 1,000. And I already know what I'm going to do to fix it. Question? No. Right, so anyways, first things first, let's just get x to 1,000. Now, I'm not going to make the same mistake last time. I'm going to first go to 1,000 and then go up, yeah. No, it will, don't worry. Now, I have a little bit of a concern with going to 1,000 because I think each number will be really, really small. And I hope each number is not so small that Excel rounds it down to 0, which is a possibility. Did you figure out what went wrong? What?
Like here, I have 0. First and last.
Yeah? You used X?
I didn't put F.
Yeah, okay. Right, I know, I think this is okay, and I just need to scroll all the way up. Come on.
What is equals negative?
Hold on, oh, that's fine. Did I get it up to 1?
Yeah.
No!
Almost.
You have to become more.
Yeah.
Yeah, but is it because this isn't exactly 2? No, this is 2. B minus A over 1,000. I have to go a little bit more, it seems. Oh yeah, one more. Yeah, that's the one. Okay, anyways. You realise, of course, it'll be quite a pain to have to click each even one and odd one. So what I'll do is I'll put the even ones here and the odd ones here. So this equals exponential minus this squared. And then I'll just, hopefully if I copy this, it should figure out I don't want it in every one. Ah, yeah. Okay, now careful. Don't go too fast. Steady. Yeah. Right, now I don't actually want the first or the last in this, which I don't have it. So these are all the even ones. Yeah. And now the odd ones starting with tray. Yeah. Okay. What? But I don't want the last one. So I'll just put it down here. Equals, where's H? H over 3. Ah, yeah, because I moved the columns over. Times the first one, that will be B1. Oh, sorry. Oh, I didn't actually include it.
Yeah.
So I need to actually put, I have to put it somewhere. I suppose there. And I'll put this one here. Okay. Oh, no, I don't want to do that. I need to put it somewhere else.
Yeah, put it D.
Another column. Okay, let's put it here. Yeah, that's the first one, and then I need one at the end. Where's it gone? Put it here. Yeah. So actually what I'll do is in this bottom column I'll put the total. So if I add up everything in, B1 to B1001, what would that represent?
First.
The first plus the last.
Yeah.
So that's the first plus the last. Okay, and then this one here, this would be all the even ones, wouldn't it? Although I don't want all the evens, I want twice them. And this one here, 4 times the odd ones. So here, it just means now all I have to do is times it by the sum of these three. Now, do I still have back? No, it's okay. It's correct to 3 decimal places. Is it 4? 4 significant figures. That might be a bit disappointing because we have to go to 1,000 to get 4 significant figures. So it's not getting to the answer that quickly. Smidge disappointing. Remember, last time I said your calculator is probably doing some method like this to get the answer. Although there are other methods than these two, but these are the two we'll study then. And this is what's on your coursework, which we said we'll do in the next class. So the plan now is I'll go print out your coursework so we can have a look at it. I think what would be good to do would be to start doing it pen and paper. And I can talk about what you need to do. So I'll go back to the office and print these, and then in 10 minutes we'll have a sort of tutorial on the coursework. Yeah? Can I close all this?